Okay, let's take a look at the next question. We're solving the triangle as well. What's very odd about this one is that I don't have a perspective. I'm kind of screwed. I don't have a perspective at all. But I do have two sides, so I'm going to have to just pick a perspective. So maybe I'll just pick this one right now. So this perspective is going to leave me with, well, this is across from that. So that's the hypotenuse, which is letter F. And then this is across from my perspective. It's opposite, so I'll label it opposite. And that just leaves this as adjacent. And some letters to go with this. The hypotenuse is F. The adjacent here is E. And this one would be D. Okay? So I've been given D and I've been given F. I just need to find E. Now, I actually can find E very easily because it's a right triangle. I can use Pythagorean theorem. Now, I have the hypotenuse. So when I have the hypotenuse, I always will subtract. So remember the formula is a squared plus b squared equals c squared. But if you have the hypotenuse, then it's c squared minus one of the legs, which is whatever, a squared equals b squared. So that's the formula we're going to use. The problem is I don't have a, b, and c. I've got, what do I have? d, e, and f. So my formula will be my hypotenuse, which is f. So f squared is, I guess, what am I trying to find here? I'm trying to find e. So you start with e squared, and then it's your hypotenuse, which is f, the biggest one, squared minus the smaller one, which is d squared. So that's how we can find e. We can find e really easy. There's no trig like SOHCAHTOA stuff in it. It's just the Pythagorean theorem, which I can do right now. E squared, because remember, we're trying to find e, and is equal to f, which is 15 squared minus 9 squared. E squared equals 15 squared, which is 225, minus 9 squared, which is 81. So I guess I'm going to have to do that. 225 minus 81, so that's going to be a 4. 22 is 14. 22 minus 8 is 14. So e squared is equal to 144. And then I can square root both sides to cancel that out. So e is equal to plus or minus 12, but we're dealing with actual lengths here, so we'll do positive. So there we have it. E is equal to 12. So that one was relatively straightforward. I found e. But now to actually do the SOHCAHTOA stuff, I need to find my angle. So I need to find D, and I've been given opposite and hypotenuse. So I'm given two things. So what is that? O and H. So O and H, which is sine. So sine of some angle is equal to O opposite over H hypotenuse. So always start with your formula. Now, sine of some angle, in this case we don't know what the angle is, it's D, equals opposite, which is 9, over hypotenuse, which is 15. Now 9 over 15, you might be wondering, what on earth is 9 over 15? Well, you can reduce that. What can they both be divided by? They can both be divided by 3. Which would give me 9 over 3 is 3, 15 over 3 is 5, which is 3 over 5. Which, by the way, if you doubled it, would be 6 over 10. So we're looking for sine of D equals 6 over 10, which is 0.6. Okay, so we need to find 0.6, and we're working backwards here. We need to find the angle, and we're doing sine. So all I need to do is look in this column for 0.6. Oh, right here, look at that. 0.60. That's really close. We need 0.6000, but that's so close. I'm just going to say that's 37 degrees. So D equals, can't remember how I did that before, but I think I wrote it over here maybe. D equals approximately 37 degrees. Now that was from me using the table. Now if you wanted to use a calculator for this, well, you need to know what to put in the calculator. And to do that, I usually go sine of inverse, sine -1 on both sides. Which is sine of D and 0.6. So those are gone. And D equals sine inverse of 0.6, which I can then put into my calculator. So 0.6 sine inverse. So 36.87. degrees. And I mean, that's also estimated. So I think the table is easier. And do I have room here? Okay, yeah. I think the table is easier, but depends on what you have. If you have a calculator, you can do this. If you have a table, you can do that. I like the table because it requires me not to have to memorize that I have to get the D alone and go sine inverse of sine and have those cancel out. Okay, so we know that. We know D is 37 degrees. So this is going to be 37 degrees. Now you could do the trick where you go 180 minus 90 minus 37 and get to the other one, but I'm just going to do it and I would expect you would do that, by the way. But I'm going to do it the other way here just to show you both. So I'm going to say, well, now I have to find E, right? Because this is 90, this is 37. So I have to find E, so I can then label this. Well, this was across from the 90. Now this side is going to be my opposite. Yeah, it's opposite. And then that leaves this side to be adjacent. So things kind of change. This used to be adjacent, now it's opposite. This used to be opposite, now it's adjacent. And so when you do that, you say, okay, I've got 15, my hypotenuse, and I've got 9. I've got A and H. So I have A and H, which is ka. So cos of some angle equals A, adjacent, over H, hypotenuse. Now the angle I don't know. That's the whole point. I'm trying to find that. So what letter is that? I think that's E. Yeah, that's E. Equals adjacent, which is 9, over 15. No. A and H, 9 over 15. Yeah, I think that's right. So yeah, adjacent is 9. So it's 9 over 15 again, even though we just did this. It is 9 over 15. So cos of E equals 9 over 15. Now remember, that can be divided by 3. Divided by 3 to get you 3 over 5, which remember was same thing as 6 over 10. And then that is 0.6. So cos of E equals 0.6. So then you can go to your chart. I'm looking for cos 0.6. Okay, that's not there. So here's cos 0.60. Okay, that's right here. That's really, really close. So that is 53 degrees. So E is equal to 53 degrees. And you could do, if you wanted to, you could do the cos -1 of 0.6. So here's 0.6, and then you can go cos -1 to get 53.13. So around 53 degrees. And that should make sense because this was 37 degrees, and 90 minus 37 would equal 53. So again, I would not expect you to do this. I would have just expected you to go, okay, Mr. Muller, I would have 180 minus 90 minus the 37 that we got, and that equals 53. And then you would have just been done. But I wanted to show you that you could do it this way as well. Why would you do it? Well, you wouldn't. But the problem is, I don't know when you're on a test which one you're going to do. Did you do so or did you do ka? I don't actually know which one you did. Either way, it'll work. So let's do one more here. Again, no angles are given, so I'm going to have to just do some perspective here. Actually, before I do that, I'll just do some labeling. So this is A, this is C, this is B. Okay. Now, A, B, C, oh, this actually works out for A squared plus B squared equals C squared. If you have two of the sides, you can do that. So we need to find C squared, and that is the hypotenuse. So when you ever find the hypotenuse, you just add the legs together. A squared plus B squared. So C squared is equal to A, which is 16, squared plus B squared, which is 12, squared. So C squared equals 16 squared, which 16 times 16 is, you can do it off to the side if you want, but it's 256, plus 12 squared, which is 144. Now, this, if you added them, C squared equals 2390. Okay, so exactly 400. And then you can square root both sides to get the C alone. C is equal to square root of 400, which is just plus or minus 20, but we just do the plus. So C is equal to 20. Okay, that's nice. This is 20. Okay, so now we're going to have to pick a perspective. So, I don't know, I'm just going to pick there. So let's label this now. Across from that is always the hypotenuse. And then if you go opposite, that is here. So that's opposite. And this leaves this, which is adjacent. So I've got opposite and I've got adjacent. O and A. So O and A, which is tan, O over A. This is a reminder of the formula, which is tan of some angle equals O over A, or opposite over adjacent. Now the angle is not given to us, but we're looking at from that perspective. So B, O is 12 over B, over adjacent, which is 16. 12 over 16, I'm pretty sure that can be reduced. Those can both be divided by 4, which is equal to 3 over 4. Now that is, 3 over 4 is 0.75. So, looking at the chart, tan, so this column, 0.75. Oh, here we go. Tan 0.75 is 37 degrees. Really? Wow. Okay. So B is equal to 37 degrees. And of course I got that from the table. Now if you wanted to do this on a calculator, you have to go tan inverse of both sides. So you would have to go tan inverse of 0.75. So in a calculator, 0.75, and then tan inverse, which is 36.86. So 36.87. This is exactly the same angle. I had no idea. So that's if you used a calculator. Okay. Now I'm not going to do the other way. I need to find, I have angle here, 90. I now know that that is 37, so I just need angle A there. So to find angle A, you would go 180 minus the 90 minus the 37, which 180 minus 90 is just 90 minus the 37. 90 minus the 37 is 53 degrees. So this is identical. I didn't expect that. Sorry, I didn't want to box that. 53 degrees. Did I put the degree symbols there? Yes, I did. So there you have it. There's the other two. So what's different about these two questions than the ones above? Well, no angles were given, just two sides. What were these ones? Well, we got one side, one angle. One side, one angle. And then in these ones down here, just two sides, no angles. Just two sides, no angles. So that's the difference. So I'll just zoom in here in case you need to copy anything down. And then we'll do the next question in the next video.